Hey everyone. So, we are going to be talking about different types of reactions today. So, there's two different ways of thinking about it. When you go about and classify reactions, there's kind of what's happening in the reaction, and then there's the what's actually going on in the reaction. Um, that's an odd way of saying things. Let me use an example. Sports. Let me use a sports example. So if I say I'm passing the ball, that's something that's happening, right? It doesn't tell you anything about what sport I'm playing, though. I mean, if I say I pass the ball, I could be playing soccer or basketball or baseball. That's that doesn't actually tell you what sport I'm playing. I could say I'm dribbling the ball. Is it basketball? Is it soccer? I don't know. I'm kicking the ball. Is it football? Is it soccer? I don't know. I'm shooting the ball. Is it basketball? Is it pool? Am I shooting pool? Um, so that's kind of what's going on. And just like a kid playing on the playground at first, you don't learn basketball. You learn how to dribble a ball or throw a ball or shoot a ball. Then you start learning how to play the sport. That's kind of what we're doing here. These types of reactions, synthesis, decomposition, single and double displacement, and combustion, these five different things are going to be what we're going to go over today. And then I'm going to switch over and kind of go all over the place, honestly. Um, and show you the three types of reactions that we're going to be learning in pre-AP. We should have gone over this in pre-AP, but I'm not for sure if you guys got to it because of the COVID. I think we went distance before then. So let's get started. So for each of these things, I'm going to go through and I'm going to be giving you a general formula. Okay. So for example, I'm going to say like A plus B goes to AB. Now, A and B can be like oxygen, potassium, and all of that stuff. But this is just going to kind of give us a format, a syntax for explaining reactions. Okay, let's get started. So first off is synthesis reactions. Now, synthesis reactions can be a generalized form is A plus X goes to AX. So basically, you're just taking two things and they're coming together. They're synthesizing. So this we can give some examples here. One thing that definitely is a synthesis reaction is oxidation or rusting. If something is rusting, then you're just taking the metal, the pure metal, in this case magnesium, plus oxygen to make magnesium oxide. Okay, you have iron and pure iron and oxygen that will react to make iron oxide, which is the red rust that everyone's familiar with. You can also, instead of oxygenation, you can have halogenation, which is basically a metal and a halogen. So you have a sodium metal plus chlorine gas will give you sodium chloride. There's different oxides that can happen where you put water with it and you can make calcium hydroxide. So yeah, this is basically what's happening in a synthesis reaction. Two things coming together to form one compound. Okay. The opposite of that is decomposition. Decomposition is where you have a compound, AX, and this will go to A plus X. So it's just the opposite of synthesis. This can happen whenever we split water. You can have water and you can split it to hydrogen and oxygen gas. If you haven't seen that, there's plenty. You can do this with a 9-volt battery and some wire. It's not terribly difficult to do. You can do this with metal carbonates. So you can, this is one thing you can do with like baking soda and vinegar. That will, baking soda and vinegar is a double replacement that's followed by a decomposition. It's a little bit more complicated than you think. But you can have something, the CO3 split apart to make CO2. So that is something that can happen here. You can kind of do the reverse of a hydroxide. A hydroxide can then form more water. Acids are another example where you can take one compound and it disassociate from itself. All right. Then you can have a single replacement. I always like to call this the I'm going to steal your girlfriend type of reaction, because it's A plus BX goes to AX plus B. So A in this case stole X away from B. So this can happen pretty often, or it's pretty common. Basically, it's where you have a metal and some sort of salt, usually an aqueous salt, so it's in solution, and then the ions that are in solution become solid, and then the solid metal goes into solution. I might go through and make a video of just some demos of these, just for funsies. So that may be coming out sooner rather than later. So yeah, another thing that I've done a few times now is magnesium plus hydrochloric acid to make hydrogen gas. This is going to be a single replacement where I have a solid metal plus an acid will make a salt and hydrogen gas. This hydrogen gas I usually collect in a test tube, light it on fire, and it goes boop. So that's that. So this is a single replacement. Remember, I'm going to steal your girlfriend. That type of reaction. Double replacement. If the single replacement is I'm going to steal your girlfriend, double replacement is, hey, let's swap partners. It is AX plus BY goes to AY plus BX. So this happens fairly often. Usually this is a precipitate reaction. This is actually the type of thing that's going on whenever we were doing those net ionic equations. When we were doing those net ionic equations, that's a double replacement. They are both in solution, the ions all get mixed up, and if so happens that one of the pairings is insoluble, all that stuff is going to fall out of solution. And you see here, this is an example of that, making this bright yellow potassium iodide. You can also, instead of doing a precipitate, you can also do a gas. So, or formation of water is also a big one. Like if you have an acid and a base, hydrochloric acid and sodium hydroxide, will make salt and water. All right. So far we've gone over synthesis, decomposition, single replacement, double replacement. And there's one other one. And this is a combustion reaction. Combustion reactions need basically two things to happen, and it always makes the same two products. You need some sort of hydrocarbon. A hydrocarbon is just something with a bunch of oxygen, or a bunch of hydrogen and a bunch of carbon. Okay, so C3H8, that's a hydrocarbon. CH4, hydrocarbon. C6H12O2, hydrocarbon. So anything with a bunch of carbon and hydrogen, it's going to be a hydrocarbon. You need this. This is going to be your fuel for the fire. Okay. As you probably know, you need oxygen for a fire, so you're going to need oxygen in this as well. And the two things that a combustion reaction makes is going to be CO2, a CO2 gas, and then H2O, water vapor. So you're going to have these two things happen. If I do go through and make videos explaining all of these, then you'll see exactly what I mean, that H2O is going to be formed, water will be formed, and CO2 will definitely be formed as well. So here are that's a combustion reaction. One thing I like to mention as well at this point is that combustion and explosion are two different things. An explosion is a rapid expansion of gas. So an explosion has a lot more to do with the ideal gas law than it does with a reaction. What we're going over now. Combustion is anytime you have a fuel, an oxygen making CO2 and H2O. That's going to be a fire, a combustion reaction. Okay, so there's that. Now, here we go. Whenever we're talking about the 3 different types of reactions that we're going to be talking about in AP, this is the sports. Okay, so the one type of reaction that we're going to be talking about is anything that makes a precipitation reaction. So a precipitation reaction is, like I said, anything that makes a precipitate. I'm not going to go over these a lot this week because we already did. Net ionic equations kind of cover the idea of a precipitation reaction. So there's that. Also, yeah, precipitation reaction. Okay. Now, the other type of reaction are acid-base reactions. Acid-base reactions are anytime you have a acid, like hydrochloric acid, or a base, like sodium hydroxide. Anytime you have these guys as part of the reaction, what is happening here? Well, anytime you have an acid, it's going to dissociate. You're going to have a anion, but you're also going to have H+. H+ is going to be kind of the key in an acid-base reaction. Okay, and the base, you're going to have the cation, but you're also going to have an OH minus. So this hydroxide ion is going to be the other side of an acid-base reaction. So anytime you're dealing with these guys, then it's going to be an acid-base reaction. I always like to think of acid-base reactions as proton transfer, because that's exactly what you're doing. H+ is a hydrogen atom that lost an electron. Hydrogen atoms have 1 electron, so they're just a proton. So it's proton transfer. OHs are going to want to steal a proton away from something. So again, that's another form of proton transfer. So that is acid-base reactions. Now, one sec. This is why I said I'm going all over the place. Here we go. So, this is a fantastic example of a redox reaction. So, what is happening here? Well, if acid-base reactions are proton transfer, redox reactions are going to be electron transfer. So you're going to have some sort of reaction going on, and if a certain species is losing an electron, then becoming a positive thing, then we call that as being oxidized. And there's going to be reasons for it, and I'll tell you the history of it later. But for right now, this is going to be a loss of electron is oxidation. And then you're going to have something, if something has lost an electron, that means another thing has gained an electron. So if you have gained an electron, we call that reduction. Okay. The way I always remember it is oil rig. Oxidation is loss of electrons. Reduction is gain of electrons. All right. And this is kind of what's happening in redox reactions. To kind of show you something, like, hang on. There you go. Single replacement is a fantastic example of a redox reaction in play. Because if you remember your oxidation numbers, I may need to go over oxidation numbers, re-go over oxidation numbers with you. Free elements are always going to have an oxidation number of 0. And this ion is going to have a, what? A positive 2. This lead is going to be positive 2. And over here, it is a free element, so it's an oxidation number of 0. And this aluminum now is going to have a oxidation number of plus 3. So, what's happening here? Well, we're going from a plus 2 ion to a 0 ion. So plus 2 to 0, that means we have gained electrons here. And aluminum has gone from a 0 to a plus 3, which means we have lost electrons. So this is going to be an example of a redox reaction. There's a lot of ways you can have redox reactions, not just single replacement, but let me flip here and go to combustion. Combustion is going to be just one big redox reaction, and you can tell because pure oxygen has a charge of 0, oxidation number of 0, and if you go to this oxygen, then you this oxygen is now -2, so it means it has gained electrons. This oxygen here is going to be -2, so it has gained electrons again. Wow, oxygen sure has gained a lot of electrons all of a sudden. Which means the carbon and hydrogen have both lost electrons. So there's lots of different ways that you can play the same game, but doing different things. You can have a combustion reaction being a redox reaction, and you can also have single replacement be an oxidation reaction. A double replacement could be an acid-base reaction, like what's happening here, or it could be, here it's going to be a redox reaction, or a precipitation reaction. Here is going to be this is going to be a redox reaction. So, double replacements can be precipitation, redox, or acid-base. Oh my. All right. Hopefully you guys understand that. If you don't, go back and rewatch the video. I'm going to be talking about acid bases and redox later on this week. So if you're not 100% on those, we'll get there. All right, guys. Have a good one. I'll see you tomorrow.